looking over there. I'm like, I think that was Ian.
Yeah. The thing is, he moved towards the ball, not away from the ball.
That sounds like Ian.
Yeah, it's Ian.
Algebra 1B. Okay, actually, I'm off by a day. Okay, but we're gonna be solving equations by adding and subtracting. We're gonna be solving equations by adding and subtracting. You guys remember one-step equations last year with Mrs. Springer?
Yep.
Okay, we're gonna be working on some of those today. Okay, so we're gonna work on the ones solved by adding and subtracting. So we'll be in 0.4. So this is the bottom of the page where we left off on last. Make sure you have your notes out. Make sure we have our notes out. There we go. All right. So this should be a review here, right? We're going to solve the equation, then we're going to check our solution. So if you have r minus 8 equals 32, how would we solve that equation, Olivia?
So you would put a line through like the equal sign.
Okay, so that's a good tip. You put a line through the equal sign.
And then you bring the 8 under both of them, and so that would make like, but you would, wait, hold on. I'm getting ahead of myself.
Cross the river. You got this, girl.
So you would bring the 8 down on both sides,
Okay.
and I think it would be negative because it's a negative.
Well, how do we get rid of negative 8? How do we offset that?
Wait,
Huh?
no.
How do you offset negative 8? Because we want to get negative 8 back to 0.
So, I don't remember.
Okay, negative 8 plus what is 0? 8. So if we add 8, what's going to be negative 8 plus 8? 0. Do we have to write r plus 0?
No.
No. So that's how we move it to the other side, is you add 8. Now why are we adding? What's the one way we can say we know we're adding? What's the opposite of subtraction? Addition. So we're going to do the opposite of whatever's here to undo something, okay? When you're trying to undo something, a lot of times you have to do the opposite of it, right? Okay? It's like if I move something too far and I want to undo that, I have to move it back. Well, I don't want the subtraction to be here because I want r by itself. So I have to undo the subtraction by doing the opposite. So I'm going to add. So now I have r on this side because my 8s, I went to 0. R equals, what's 32 plus 8?
40.
40. Yep. And we have to keep it balanced. We have to keep the equation balanced. So we have to add 8 to both sides. We get r equals 40. Now, how do we check our solution? Somebody help me on how we do that, Abby?
You plug in 40 where R is supposed to be,
Yeah.
minus 8.
So you plug in 40 for r and say 32 or 40 minus 8 equals 32. Now, something I do is we're trying to ask a question here. We're saying, does this equal? So I'm going to put a question mark above it. I'm going to say 40 minus 8 equals 32. Guys, when you ask a question, right, you inflect your voice a little bit. Like, hey, where are you going? Like, you have your voice go up a little bit at the end. And does anyone notice you do that? Yeah. So it's the same kind of thing. So I always just say 40 minus 8 equals 32. So what is 40 minus 8? 32. So what does 32 equal 32? So I always say, check, it checked out. We're good to go. Check, it checked out. We got the right answer. Now, during homework and tests and quizzes and everything, I'm not going to make you check your answer, but if you check your answer, do you know whether you got it right or wrong? Yeah, so it's pretty handy. It's pretty handy to know how to do. Okay? Then you want to keep that away though?
Yeah, I'm using my calculator.
Yeah, we're going to try not to use calculators during class for the best we can, okay? So, next problem. H minus 12 equals negative 27. So, we can draw the line through this every time. We don't have to if you don't want to, okay? That's a great organizational method though. But if you want to keep drawing this line through the equal sign, you definitely can. You don't have to, okay? So, here, what's happening to H? What's happening to our variable H? We're doing one operation to it.
Subtraction.
Subtraction. So how do we undo subtraction? Okay, Tobin.
Addition.
Addition. So what are we going to add to both sides here, Olivia?
12.
12. Now, why are you saying we're going to add 12? I agree with you, but why?
Because it's like the smaller number, and you can, well, and.
Can anyone help Olivia on why we're choosing 12? Okay, why aren't we adding like 8 or something like that, Maddie? Okay, because that's what we're subtracting by. Okay, we're gonna add by what we're subtracting by. We're gonna do the exact opposite, subtracting 12. The exact opposite of that is adding 12, the same number. Now can I just add it to one side?
No, you have to add it to both
So I
sides.
have to add it to both. Very good. Okay. So what's negative 12 plus 12? 0. Gone. We took it away from this side. So we just have h equals. Now we have negative 27 plus 12. Negative 27 plus 12. What happens when you have two different signs, a negative and a positive? Olivia?
What do you call it, the bigger number?
Okay, the sign is of the bigger number, so it's going to be negative or positive.
It's gonna be negative.
It's going to be negative because 27 is bigger than 12. And how do we know what our answer is? You subtract them. When they're different signs, you subtract them. And you just take the sign whichever number is bigger. So what is 27 minus 12? It'd be negative 15. So our h is equal to 15 is our answer. Now we go back through and we can check this, right? So we plug it in for h. Negative 15 minus 12 is equal to negative 27. And I'll say equals. It does. Okay. Now negative 15 and minus 12. Okay, are those the same sign? I can see your house. Yeah, I'm so offended. So what happens? I heard someone say, what happens when we have two negatives?
You have to add.
You add them, same sign, add, and you keep the sign. So what's 15 plus 12? 27, but it's a negative 27. So does negative 27 equal negative 27? Yep, check. It checked out. Okay. Questions on that? All right, let's try this next one. Okay, I want you guys to actually try this next one on your own. I want you guys to try this next one on your own. So let's do 5 equals x minus 10 on your own. If you have it or have questions, raise your hand. Number 3. Yeah. Very good.
Some coffee toys, or Tucker. I had the tea right,
Oh, okay,
right?
you're over there. Okay. Very cool. Bigger.
You have to add the 10 to 3.5.
Hey, be careful, guys. It's not 3.5. This is number
Oh.
3, and it says 5 equals.
Oh, okay, then you're right,
Yeah.
I apologize. You're right, I thought it said 3.5, so I'm,
Wait,
so I did it wrong.
So.
Yeah.
So. Which one?
Yeah.
See, it makes a lot of things, thanks a lot easier.
It does.
It makes a whole lot easier, I did 3.5.
Yeah.
You get it, Joe?
Yeah.
Okay.
There you go.
I'm not done yet.
All right, we'll talk about this one up here. So, what would we do here in this problem? Tucker, add 10 to both sides. So we have x minus 10. Let's add 10 to undo the subtraction into both sides. Now it's 10, 5 plus 10.
15.
15. We still have our equal sign here. If you want to build a line through to help remember that, you can. Okay? X is still here. What's negative 10 plus 10? 0. Negative 15 equals x. X is by itself now. Now we can go back through and check, right?
Yep.
Okay. So 5 equals 15 minus 10. What is 15 minus 10? 5. Does 5 equal 5? So yep, it checks out. Check it. Checks out. Okay. Questions on that? All right. Okay. Let's go on to number 1 right below this. What are we doing now instead? Instead of solving by addition, we're going to be solving by subtraction. Are we doing the same kind of idea though? Yeah, I think we are. Okay. So I want you guys to try number 1. And if you you have any questions, raise your hand, or if you have it, go ahead and raise your hand as well. We did do all of them. We're just doing number one right now. All right, let's talk about this one up here. So k plus 63 equals 92. K is not by itself. We want it by itself. So how do we undo what's happening with k? How do we undo the addition of 63?
Yes,
Gotta subtract 63. Subtraction is the opposite of addition. So we're gonna subtract 63 from both sides. Gotta be equal, okay? So what's 63 minus itself?
0.
0, just k on this side. Equal sign. Don't forget about that. If you want the line there, you can put the line there. 92 minus 63. What is it, Tobin?
29.
29. I agree with you. K is equal to 29 here. Now let's check our solution just to be careful here, okay? Once again, I'm not going to make you guys do this on homework or tests or quizzes, but it's a good idea if you have the time, okay? So 29 plus 63 equals 92, okay? So 29 plus 63, does anyone know what that does equal? Let's go over the side and do that. What's 3 plus 9? 12, so 1 and 2 down below. What's 6 plus 2? 8 plus 1? 9, so is it 92? So does it check out? Yeah, 92 equals 92. Check, checks out. I want you guys to try number 7. Any idea when you're done? Where our questions raise your hand. Very good.
Yeah.
Did it again.
I didn't get it. I kept reading it. Yep. Open's right.
Very good.
Yes.
Now, are you gonna sit when I'm talking to another student? Is Hasmus talking to you? Okay.
Okay.
Very good. We'll talk about that here, okay? So on number 2, let's talk about this one up here. 7 equals 42 plus t. What's going on with our variable? We're doing what with it? It's being added with 42, isn't it? But what we're going to do to fix that is subtraction, okay? So I'm asking the question before that one. Is what's happening with our variable? We're adding it with 42. How are we going to do addition? Subtraction. So we're going to subtract 42 from each side. We're going to subtract 42 from each side. If you want to do that line with the equal sign again, you can. So we have 7 minus 42. Are those same signs or different signs? Different. A positive 7 and a negative 42. So we subtract them. What's 42 minus 7? 35. Which number is bigger though, the 7 or the 42? So it's a negative 35, right? 42 minus itself is 0, we got rid of it, now we're left with t. So negative 35 is equal to t. And we're done with that problem. We'll check it though, just in case.
I think we need to next year do the little parentheses instead of the dots. Like 2.7.
Oh, first, okay.
Because to me, it looks like I've done it every time, 2.7, so I'm making it harder than it has to be, and then it's shocking, but maybe it's just me too, so.
No, I understood it.
Okay, no, yeah, that's, thank you. I mean, good feedback for darn sure. Alright, so 7 equals 42 plus negative 35. Okay, what's 42 plus a negative 35? Those are different signs, we subtract them. What's 42 minus 35? 7. It's still positive because 42 is bigger. So does 7 equal 7? Check, it checks out. Alright, let's try number 3, okay? Let's try number 3. Once again, once you have it or have questions, raise your hand. Ooh, lots of hands go up.
On my moving.
You guys working ahead a little bit. Good for you.
Okay. What are these? Okay, so if you take a negative plus a negative, you get a negative number.
No.
Because you're taking 21 away from it, so you add these together.
Yes, ma'am, it would.
For multiplication, we would do 2 negatives. Yeah. So let's talk about this up here, guys. What's going on with our Q? We're adding what to it? 21. Now we want to undo adding 91. So we're going to do what with 91?
Minus.
Subtract it, minus, okay? So subtract 21 from both sides always. 21 minus itself is? 0. Q equals, are these the same sign or different signs? Same. Same sign, add, and you keep the sign. So what's 18 plus 21? 39, but it's negative, right? Because we're keeping the sign. So negative 39, and we'll go through and yep, we'll check it again. So 21 plus negative 39 equals negative 18. Or I should say equals negative 18. So 21 and negative 39, same or different signs? Different. So we subtract from 39 minus 21. 18. Okay, 9 minus 1 is 8. 3 minus 2 is 1. 18. But it's negative because 39 is bigger. Does negative 18 equal negative 18? Yeah. Checks out. Questions on these? Okay, continue on to the next page. We have a little bit on this back, okay? What color should I pick?
Blue. Light blue.
Light blue. Okay. So, solve y plus 4/5 equals 2/3. Ooh, fractions. Fractions. Ew, gross fractions. Okay? So, we'll work through them, though, we'll figure them out, okay? So, what would we do? Well, let's first of all say, is y by itself? No. What's happening with y?
It's
being added with 4/5. So, how do we get rid of addition? What are we going to subtract by? 4/5, exactly what's there. You're nailing it. Now we're going to do that on both sides, right? Now here's the thing. What's 4/5 minus itself? 0. Anything minus itself is 0. Now, do we know off the top of our head 2/3 minus 4/5? Does everyone, you guys don't have that memorized? What? No? Oh, okay, me either. Okay. So 2/3 minus 4/5. What do we need in order to add and subtract fractions? Common denominators. You guys are nailing this. Mrs. Springer must have done really well with your guys, okay? So what's going to be our common denominator here? Do we know? Abby, what are you thinking? 15, yeah, we can multiply both to 15. So what are we going to have to multiply the first one by to get to 15?
5.
What about the second one?
3.
3. Okay. Now is that just multiplying it by each other? Right? Or excuse me, is that so see how the denominators are both 3 and 5? A little trick is you can always multiply one by the other and you'll always get a common denominator. It just might not be your lowest one. You might get bigger numbers than you need. Okay? Now you guys can do this a few different ways. Something I'm gonna have you guys do, and something I'm gonna have you do, or I'm gonna show, I should say, is I'm gonna multiply this one by 5 over 5. Multiplying by 5 on the top. Multiplying the one on the left, on the right, excuse me, by 3 over 3. I'm gonna write that little dot, I'm multiplying it. And I'd recommend writing it a little bit smaller than normal numbers, so that way you try not to confuse them with your normal numbers, okay? If you want to, you can also do this off to the side and say, okay, I'm going to do 2/3, and I'm going to multiply this by 5 over 5, and say, okay, what's 2 times 5? 10. What's 3 times 5? 15. And say, okay, now I'm going to do 4 over 5 times 3 over 3. What's 4 times 3? 12. What's 5 times 3? 15, okay? Is that easier for you guys to do it off to the side or do it in the problem? What's that?
I think we'll have the same result.
Yeah. Now let's keep going then and talk this through. So either way, right here, we'd end up with 10 over 15 minus 12 over 15. So whether you guys want to do this inside the problem or outside the problem right there, either way is fine. So the red part you can do in either spot. The red part you can do in either spot. Now how do we combine these? What would 10 15ths minus 12 15ths be? Are those same signs or different signs? Different, positive, negative. So we subtract what's 10 minus, or 12 minus 10? 2. Which one's bigger? 12, so it's negative, right? So this is y is equal to negative 2 over what? 15. The denominator stays, right? We just did all this work to get common denominators. Let's not throw it away now. We just did all this work to get common denominators. Let's not throw it away now. Okay? Questions on that? Okay? Ooh, fractions, right? We love them.
Was that negative 2?
Negative 2 over
2/15.
Yep, negative 2/15.
Okay.
Yep. Okay. On number 2, 1 is equal to x plus 0.356. We got some decimals here. Let's cross through some decimals. You thought you'd like those, okay? I'm not going to make you check on number 1 though. Be good. 1 equals x plus 0.356. So what's happening with x? What's happening with our variable? We ask ourselves this question all the time. What's happening with our variables? Added. How do we undo it? Subtract. So what are we going to subtract by?
0.3656.
No, we're going to subtract by a decimal there, right? On both sides. Okay. Now what's 1 minus 0.356? Anyone know off the top of their head? No? Okay, that's okay. I was kidding. Yeah, I don't expect you to. So what we can do is we can put 1 and then just write it up above here. But we're going to line it up, right? So the 1's, they're going to go right above the 0. So we're going to have to put after this 1.
Zeros.
Zeros, and we're going to have to put a decimal there, right? Very good, Maddie. Now can we do 0 minus 6? No, we're going to have to borrow, aren't we? Where are we going to have to borrow all the way from? One over here, the 1 becomes 0. The 0 becomes 1, but then it becomes a what? 9 again. This becomes 10, then it becomes a 9. This becomes a 10, and this becomes a 9, and this becomes a 10. So now we have 0.9910. What's 10 minus 6? What's 9 minus, I'll slow down a moment. Good? Okay. What's 9 minus 5? 4. What's 9 minus 3? 6. Now we have our decimal. 0 minus 0? 0. So it's 0.644. Equals x. And what's 0.356 minus itself, guys? 0, we got rid of it. So our answer is 0.644, or just 0.644 if you'd rather, is equal to x. Questions on that? Okay. So decimals and fractions, are they impossible for us to do? No. Is it a little more work sometimes? Yeah, it's a little more work, but we can still do it. Okay. Let's look at number 3. A plus 1 equals 2 sevenths. A plus 1 equals 2 sevenths. Okay? What's happening with our variable A? Adding. How are we going to do it? Subtraction, right? What are we going to subtract by? 1. A is equal to 2 over 7 minus 1. Now, we have to get what in order to subtract these? Common denominators. Now, what's the denominator of a 1? We don't see anything there. 1. It's always over 1, isn't it? Any whole number is over 1. Now, we can do this work off the side or once again inside, but what's our common denominator going to be? 7. We have to change our first one at all? No, what do we got to do to the second one? Multiply by 7 on the top and the bottom, right? Maybe we don't just want to leave part of it out. We have to multiply the top and the bottom. Okay. Multiply the top and the bottom by 7 there. So now we're going to have A is equal to 2 sevenths minus what? 7 over 7. And what is 2 sevenths minus 7 sevenths? 5, what are you thinking? What kind of 5? Negative 5 over 7. Because what number is bigger, the 7 or the 2? 7. So we say it's negative. Okay? So they're different signs, positive and a negative. Subtract them. 7 minus 2 is 5. But if the 7 is bigger, it's negative. And we always keep the denominator. Once again, we just went to all that work to get common denominators. We're not going to screw it up, so we're going to save it. Question on that? Alrighty. So, do you guys remember how we had all these expressions before? And then we turned them into algebraic expressions? We're going to practice the same thing right here on number 4. We're going to practice the same thing here on number 4. 14 more than a number is equal to 27. 14 more than a number is equal to 27. Find the number. Okay? Who can help me with this one? Lainey.
Do you want me to tell you like the equation?
Yeah.
14 plus x equals 27.
Exactly right. 14 more than a number. 14 plus. More than means plus. We can always go back to 0.1 and check that out in our table. A number means a variable. Lainey chose x. Is equal doesn't mean equals. 27. Now we're asked to find the number. Find the variable, right? Can you guys solve this one? I think so. Okay, go ahead and solve this one for x. Once you have any rough questions, raise your hand. So we get this one together.
Oh, sorry. Yep, you're good. Reagan, you're wrong. Just teasing. I'm teasing. Sorry. You're good. I'm just playing with you, sweetheart. You're using that
one of the harder ones. You can't
I'm
do
really
it.
good at the double person.
Really good at these math.
I'm really good at these and you're assuming they're really bad.
How do you do on multiplication and division?
Okay, or Foxville.
Yeah.
Is that where the buildings are on there?
I think so.
How is it actually?
It's actually,
Close to an hour and a half.
like, just about 2:30.
So 14 plus x equals 27, so how would we solve this? Okay, Olivia?
You would subtract the 14 and then you would subtract the 27 from 14 and that would give you x equals 13. Positive 13.
Yeah, positive 13, because they're different signs to subtract. 27 is bigger though, so we say positive.
Mr. Frost, can I just tell you how proud I am of that girl?
You betcha.
That the whole draw the line, because she was speaking my language, because she would get confused, so that's why we was doing the
Yeah.
line. And now look at you, you don't have to draw the line, Olivia, I'm so proud.
Good stuff, that's awesome. That's awesome, we love success stories. Any questions on number 4 here? Alright, we got one more problem today, okay? One more problem today.
Oh.
It's alright, I'll
It's
be
a
with
word
that.
problem.
That bad.
Hey, what color should I pick though for this
Ooh,
one?
fun.
Pink, red,
You know that big one there? Oh.
Yellow,
Green.
blue, yellow.
You can barely
Yellow.
don't think it wants you to sound
Okay.
like color.
What color should I pick?
Blue.
White.
Red.
Not light pink.
White.
Yes.
You can't do the equation if it's white, buddy.
I mean, you can.
The Washington Monument in Washington DC. You guys know what the Washington Monument is?
Yeah.
You know, the big tall one?
Yeah.
Was built in 2 different phases. So it was built part of it at a time and then they had to stop construction. And they built more of it. During the first phase, the monument was built to a height of 152 feet. During the second phase, additional construction resulted in the monument's final height of 555 feet. How much of the monument was added during the second construction phase? Write an equation to solve the problem. Now here's something I like to do with word problems, okay? Here's something I like to do with word problems. Is I like to go through and underline key information. So raise your hand if you think you know something in this paragraph, in this word problem, that might be key information. Emily.
During the first phase, it was built.
Okay?
Underline first phase and then underline 152.
Ooh, I like that, okay? So Emily was saying, hey, during the first phase, we need to know it's built to 152. So we don't have to underline the whole sentence. Let's underline first phase and 152 feet. That way we know that's the initial, okay? I love that. You can shorten down or underlining, okay? Tobin, what's another piece of key information?
During the second phase, it was built to, the final height was 555 feet.
Okay, so we kind of have a couple things in there. I think we can even break that apart into 2.
Yeah.
Break that apart into two different ones there, okay?
Underline, second phase, and
Okay.
then the 555 feet.
Okay. Let's actually go second phase and then underline something else with second phase. Now tell me what I would want to underline second phase besides 555. I think we're gonna save that for another thing, okay? Reagan.
Additional.
Additional. Second phase, additional construction, okay? And then what's the other thing we want to underline with the 555? Because Tobin's right, we want to underline 55 feet. What do we underline with that? Okay? What do you think, Delaney?
Final height.
The final height, okay? Now, we're trying to figure out how much was added during the second construction phase, right? That might be important to know, okay? So how much was added, okay, during the second phase? Okay, during second phase. That's probably pretty important, right? Okay? And tell us to write an equation. Can anybody help me write an equation, especially now that we went through and underlined some key information, okay? Abby.
152 plus A equals 555.
That's exactly right. Can you tell me why you got that?
I got that because the first phase was 152.
Okay,
Then it says additional, so
Yep.
you add,
okay.
but you wouldn't add 555 because we want to know how much was added during the second phase.
Mhm.
And it says final height, so that would be the final. So you put an A, and then equals 555.
Very good, very good, very well worded. Any questions on how we got that or how Abby came to that? That's exactly right. Now, do we have to use A? Could we use a different variable?
Yeah.
Sure, you totally could. A is just fine. And now, can we solve this one?
Yeah.
Yeah, because what's happening to our variable? added. How are we gonna do that? Subtraction. Aiden, what would you subtract? What would you subtract? We said we need to subtract. What would you subtract? Would you subtract A? Okay. You subtract 555? Okay. Is that what's with the A right now?
Oh, wait, no. Sorry, subtract 150.
Okay, very good. Why did you change your mind?
I got flipped around.
Okay, okay. So we want to subtract whatever's with the A. What's 152 minus itself?
Oh,
0. Oh, I got you there, Tucker. Now 555 minus 152. This is kind of convenient. You can go straight down. Olivia?
2? No, 3. Wait, what was the question again?
555 minus 152.
Oh, 403.
403. Oh, you were doing 5 minus 1,
Yeah.
you know?
She was doing the problem with
Yeah, you were going with me. 5 minus 2 is 3, 5 minus 5 is 0, 5 minus 1 is 4. And now this is 403 chickens, 403 ducks, ostriches, canoes,
Feet.
feet.
Thief.
We don't want to forget our label. So how much was that during the second phase? 403 feet. Okay? Any questions on that? You guys are rock stars.
Yay.
How much different it is how fast we can get through notes when everyone's quiet and pays attention, huh?
Isn't it crazy?
Yeah.
Oh,
That's just-
that's such a
Oh
stressful
my
one
God.
for new freshman year. Math class.
What was stressful?
So mine was it?
Wait, what?
What was
Well,
stressful?
two
Math
minutes, guys.
last year,
I
I didn't
think we're
understand.
Yeah.
Well, that's the one I'm taking.
Me too.
I've already told you to There's always German and French classes.
What?
German ones I never ate. I'm like, can I be tough for years? Like, I guess.
Oh, yeah. Yeah, I remember that.
Oh, wait, yeah, you were in our
Yeah.
Olivia, you should have seen how
Put that
proud
again.
my heart was
No,
when you
you
said,
wasn't. Oh, you
roll the
were.
line.
Alright. Hey guys, do you want to do all of these?
Sure.
No.
Don't-
No? Okay. Don't do 16 through 20.
Yay.
I mean, you can if you want to, but it won't be up to credit. So, don't do 16 through 20.
Is it okay with listen to music?
You can listen to music. And if you want help at all during this, or raise your hand, Former Practice has one